Welcome back to class number 10, where we are doing more examples. This time it looks like we're going to do English units, or I should say American units, because I don't believe the people in England use these units anymore. So we have the same problem we had previously, but now just using British gravitational. And the vessel, having a volume of 100 cubic feet, contains 1 cubic foot of saturated liquid water and 99 cubic feet of saturated water vapor at 14.7 pounds per square inch. We assume that's psi. Heat is transferred until the vessel is filled with saturated vapor. Determine the heat transfer for this process. So one of the ideas that we would want to look at as part of this is to recognize what they're talking about, that we are at a mix. So we're somewhere here underneath the vapor dome where we have part water and part steam, and we would like to heat, and because it's a rigid tank, it's going to be the same. Oh, by the way, you have to give this thing a thing. Let's go temperature versus volume. Because it's a rigid tank, the volume of the tank doesn't change and the mass inside of the tank doesn't change, so we have the same specific volume. And we want to find how much heat is done in this transfer process if we go straight up. And so we fill it with a saturated vapor so that it's 100% saturated vapor, meaning that it's touching on the vapor dome. Ta-da. Okay, so we're going to go into the tables, and in the U.S. tables in our book is an F, and I believe F7. So let's take a look, and we're going to try to find, I think it's actually F7.1 that we're going to look at. We're going to go to T, well, really pretty much P is equal to, let's say, it's going to be P is equal to 14.7 psia, but it's actually this. We have it. This is the temperature indexed one right here, so it's actually going to be at temperature 212 point something or other Fahrenheit. So let's go and get that information. I'm always doing this. I never save them though. I don't save anything. So let's go down to F and F7 right here. So let's take a look into here, and here you go, 14.7. So there you go. There's the information we need, and we will hit up with the highlighter there. We need to write all this stuff down. So we go VF is equal to 0.01672, and these are going to be cubic feet per pound mass. Cubic feet per pound mass. And then the FG, do I need that? I'm going to write it down anyway. I started to 26.786 cubic feet per pound mass. And VG of 26.8032 cubic feet per pound mass. While we're here, we want the internal energy, the internal energy that's going to be BTUs per pound mass. And so there's VF, not VF, UF, silly man, 180.09 BTUs per pound mass. I don't think I need, I think I can learn my lesson from the last video. I don't need the FG, I need only the G in this one. 1077.60 BTUs per pound mass. And so with that information right there, first I might want to get what the mass is, what mass is into this thing. I guess that's what I decided to do. So I'll take this VF and compare it to this one right here, right? So we'll go M is equal, I'll go fluid is going to be equal to the volume of the fluid divided by the specific volume of the fluid. That's state 1, I should point out. And that's saturated liquid. Yeah, okay, you got that. 0 and 0.01672. And what we're going to end up with is 50, I can't tell if that's a 54, it's a 59. 59.81 pounds mass. mg, same thing. Get the gas, which is 99, divided by Vg. So 99 and 26.8032. I have the sig figs, so might as well use them. 3.694 pounds mass. And then, so the M total. Did I write the M total? I should write the M total somewhere. There you go. M tot. MF plus mg. And so 59.81 plus 3.694 is going to be 63.5 pounds mass. Okay, so the initial internal energy is going to be, I'll go M fluid times U fluid plus M gas, U gas. M gas, U gas. So we go 59.81 times 180.09 plus 3.694 times 1077.60. I'm going to leave myself enough room for the equals, so just one, put it over here. So it's going to be 14,570, 751, sorry, a little dyslexic there, 751 BTUs. We need to know what the specific volume is of the total thing. And we could play around with these up above, but it's probably just as easy to go 1 equals 2, whatever it is going to be the total volume divided by the total mass. Or 100, I should have done it up above, 63.50. So we get 1.575 cubic feet per pound mass. And so now we want to, as we mentioned before, we want to search through these steam tables so we find a location where it has that specific volume for saturated liquids. And that's going to be, so let's see, boom, maybe make it a little bit better right here. So we're looking for 1.57 out of this column, which we don't see anywhere in here. And we have to go to the next portion of it. So go, oh, right here, between here and here. We are looking for 1.575, and that looks like we found it. And that's going to be, it looks like it's nearly halfway in between 410 and 420 in the temperature, right? We don't have for the English units, we don't have an indexed thing by pressure. All we have is for the temperature. But we can go ahead and from this use, oops, let me highlight these two things right here. So I'm going to highlight both lines so I can remember, I can use them. I need to change the scroll method. Let's take this guy and use him again. All right, so here's my interpolation little routine if I want to be a cheater, but I just don't think it's really cheating. Let me start out with the temperature. So I'm going to go 410 No, that's not where I want to do it. I want to go. I need to go this one first. I need to go saturated liquid over on this side. So 1.6537. Boom. And now here needs to be the thing I just calculated, 1.575575. Okay. And now here's down to this one right here, 1.5023. 1.5023. Boom. And now here's the temperature, 410. And here's 420. I'm pretty sure it's like 415. Yep, pretty close to it. So I'm going to write that down. So this is table of F.7.1. Interpolate. So T is equal to 415.2 is good enough. The pressure, I'm going to do the pressure. That's going to be 276.48 and 308.52. Boom. And so the pressure is 293.1. Good enough for. And then the last one, here's the most important one, really what we're out to get. Let's use the gas right here. And you notice there's very, very little difference between them. So there's, we probably, in the big picture, don't need to go crazy with it, but let's go crazy with it anyway. Go 1,118.32. And so what we end up with is a U2. It's a good band. 1117.95596. That's a lot of sig figs. And these are BTUs per pound mass. Right? Interpolating with a little table makes it a lot easier, huh? And then so what we'll get. I'm looking at the wrong page right here. Sorry. I was like, what is that? Those numbers are terrible. Like, no, it's okay. We can get what big U2 is going to be. It's going to be M tot times U2, or 63.50 times 1117.96, and that gets us 70,993 BTUs. And so therefore Q1 to 2, I should have gone through, because on the previous video, let me see, I didn't do it here, but I should. This would be good practice. Note that, here's the big equation that we were using. Work between 1 and 2. But this is equal to 0 because there's no volume change, right? So therefore, Q from 1 to 2 is just going to be U2 minus U1, which is going to be 70,993 minus 14,751. So here's our answer. It is going to be 56,242 BTUs. It's easy when you know what once you see it, right? But this reading it from here, it's a little challenging. Your brain can turn off when you're reading these words. So it's a simple problem. We're going to get more complicated. That's enough for this video. Do another example.